Okay, we'll be wrapping up Chapter 11 today and Wednesday and doing the Chapter 11 test page sort of for your assessment on Friday. And then next week I'm going to just do a few lessons of Chapter 12. We will not finish all of Chapter 12. And then try to get all of you caught up and getting your assignments in so that I can get the grades in Skyward. So this is Chapter 11, Lesson 8. You'll notice it says Day 1. I'm splitting it into two parts because one part is solving equations and another part of it is graphing. So it's not completely unrelated, but I think you can focus on the two different parts, part Monday and part Wednesday. So for today, Lesson 8, we're going to talk about rational equations. It says in functions because these equations are functions, meaning that for every x value that you put in for an input, it has exactly one output. Example 1 on this note sheet, I guess, is different than example 2 and example 3. We take a look, compare them to each other. See if you can notice a difference between example 2 and 3 when you compare it to example 1. Because it'll determine on how you attempt to solve it. So in example 1, you should not see any addition or subtraction signs in the overall problem. Not necessarily in the denominator or in the numerator, but I'm talking about in the problem itself between the rational expressions. So no addition or subtraction signs in the rational expressions. This again, if you go back to lesson 1 of chapter 11, looks like a proportion. So we are going to solve it using cross multiplication or cross products. Like we did in lesson 1. All right, so we are going to take x times x minus 4. Put an equal sign in the middle. And 3 times 4, or 4 times 3, on the other side. And we've worked with these already in lesson 1. Distributive property, x squared minus 4x equals 12. I'm going to repeat again that if you have an x squared and a term that has just an x with an exponent of 1, you need to move everything to one side, factor, and solve. If you just have an x squared without the x term, then you can get the x squared by itself on one side and find the square root of both sides. Or if you only have an x but no x squared, then you can just solve for x. So there's so much detail to this, and you need to know what strategy to take based on what you have, almost like analyzing each step to figure out what you need to do next. So I need to subtract the 12. I need to factor this. See how important that factoring is? I've been talking about it all of chapter 11. So if chapter 10 was difficult, this will remain difficult. Algebra 2 is really heavy in factoring and new types of factoring. So from here, I need to find two numbers that multiply together to give me a negative 12 and have a difference of negative 4. So what times what makes negative 12, but when I add them, I get negative 4. So that should be a negative 6 and a positive 2. When you solve this, you will get x is 6 and negative 2. Then you need to make sure that you take these two numbers and go back to the original problem's denominators and make sure that you can put the 6 and the negative 2 in for x and not get 0 in the denominator. So when I look at the original problem, the only number I would not be able to use as a solution would be 4, because 4 minus 4 would be 0. I did not get a solution of 4, so both these numbers are solutions. X could be 6 or negative 2. Okay, example 2 and example 3. Just so that I can write larger and stay on one piece of paper, I think I'm going to use a blank piece of paper for example 2. If you would like to also, you can do the same. So I'm going to rewrite example 2. That'll give you a chance to write it maybe as well. So leave space on the left side of your problem. 2 over 5x equals, I'm just going to take the negative sign on the example. Remember, it can be a negative fraction, then negative can go in the numerator. That's where I'm going to put it. It could also have gone on the 15 in the denominator, but not in 2 places, because then your fraction's positive. Okay, so this is what example 2 looks like on your note sheet. This strategy for example 2 and example 3, I'm going to call it multiplying by the least common denominator. Okay, so again, all those grade school things coming into place, knowing what a least common denominator is. So you're going to use this strategy when you see an addition or subtraction sign between rational expressions, fractions. So we have to find the least common denominator. What that does for us is if we multiply both sides of this problem by a least common denominator, you won't have any fractions anymore. Voila, you're going to love this strategy because you don't like working with fractions. Okay, so I'm going to multiply both sides by, when you look at this denominator, you see a 5 times an x. I'm just going to write these on the side. I have a 5, I have an x. I have a 15. A 5 is part of 15. 15 is like a 3 times 5, right? So if I'm already using 5, I just have to make sure I also use the 3. And then this has an x in the denominator, which I already have. So I'm going to say that my least common denominator is 15x. That's me taking all of these separate parts and multiplying it together. Okay, so if I multiply this side by 15x, I'll say over 1. And this entire side, I'm going to use the distributive property. 15x over 1. Okay, and then I want you to look at it just one part at a time. Don't get overwhelmed by how big this looks. So if you have 15x over 1 times 2 over 5x, you can cross reduce. 5x is going to go into itself once. 5x will go into the 15x 3 times. 3 times 5x makes 15x. So now all I have to do is multiply the 3 times the 2, and I will get 6. Told you it would get rid of any denominators. Okay, so 15x over 1 times 2 over 5x. If you don't like the cross reducing, you can just do 15x over 1 times 2 over 5x equals 30x over 5x. And then see that the x's cross off and 30 over 5 is 6. You could do it that way as well. So in multiplying all of this, all I got was 6. On this other side now, I need to use the distributive property. I'm going to tear off a piece of paper here. I'm going to cover this up, okay, because I am doing 15x times negative 3 over 15. I'm multiplying this fraction times this fraction. So if I multiply a negative 3 over 15 times 15x over 1, can you see that the 15s will cross reduce? 15 out, 15 out. I have just an x left. So negative 3 times x will give me a negative 3x. Okay, that is the 15x over 1 times the negative 3 over 15. I move this over because I'm doing the distributive property. Now I'm multiplying the 1 over x times 15x over 1. The x's cross reduce. I have 15 times 1, so I will have plus 15. That is a lot of work up there. Okay, it looks kind of dizzy. Make sure you just take one step at a time, and I'll do some more examples. But I now am down to this problem. I'm going to realign that. 6 equals negative 3x plus 15. Okay, so at this stage, you can just subtract the 15. You're solving for x. Oops. Divide by a negative 3. And x equals 3. Again, you need to go back to the original problem and see if you can place 3 in your denominator without making 0. And that is fine in this problem. So 3 is your solution. Okay. That was example 2. I have a little bit more room on this piece of paper for example 3, so I'm going to go ahead and do example 3 on the paper. So if you noticed in example 2, we didn't have any trinomials or binomials that needed to be factored to find the least common denominator. But in example 3, you do. So I'm going to factor this. You cannot use this as it is. You need factors to find the least common denominator. So you need your two numbers that multiply together to give you a positive 14 and add to negative 9. Blank plus blank is 14, positive 14. Oh, I'm sorry, times. But when you add them together, you get a negative 9. Those numbers should be negative 7 and negative 2. That means that your common denominator, or what you are going to multiply both sides of this problem by, is that x minus 7, x minus 2. I am going to do it on separate paper. Alright, this is Mrs. Stofflet rewriting this same problem. Leaving space on my left. So I'm going to have 3 over x minus 7 plus a big 1. It's just the number 1. 8 over, and I'll write it in factored form, x minus 7, x minus 2. Alright, I'm going to multiply this entire side by x minus 7, x minus 2 over 1, and this side by x minus 7, x minus 2 over 1. That looks like so much. Keeping that equal sign in the middle, take a look at multiplying this and cross-reducing. You have the same thing in this numerator as you do in this denominator. If I cross those out, I now have 8 times 1 over 1 times 1. 8 times 1 is just 8. This whole side, all of that just became the number 8. So while it might look messy when you're showing your work, the reason you're doing it is to make it so simple. Okay, other side. So what you do to one side, if you have an equation, right, balancing this equation, if I multiplied this side by x minus 7 times x minus 2, I have to do the same thing on the other side. This side's the distributive property. So one part at a time. So I am really just multiplying this fraction times this fraction. If I cross-reduce, this x minus 7 and this x minus 7 cancel out. So literally I need to do the 3 times x minus 2. I'm just going to write that over here just like that. 3 times x minus 2. Okay, again, cross-reducing 3 times x minus 2. Then I have an addition sign, right? Distributive property. I just multiplied this and got this. Now I'm going to multiply this times 1, so that's not so bad. So I'm going to write x minus 7, x minus 2, because if I multiply it by 1, it equals itself. All right, this is where I am right now with my problem. I need to multiply all my parts back together so that I can combine everything, move it all to one side, factor, and solve. Okay, so I'm going to have 3x minus 6 plus, now this has already been multiplied together in your problem, but I've noticed that some people have forgotten how to do this, so it's FOIL. First, x times x, outside, x times negative 2, negative 2x, inside, negative 7 times x, and those last two parts, negative 7 times negative 2, positive 14. Combine like terms, so I only have 1x squared. I have a 3x, a negative 2x, and a negative 7x. So if I add all of that together, I should have a negative 6x. I have a 14 minus 6, which should be 8. And then on the other side I have an 8. So if I move this, remember I said move everything over, factor, and solve. So if I subtract the 8, I'm actually just going to have x squared minus 6x equals 0. Again, a few people forgetting how to factor a binomial. You just look for a common factor, which they both have an x. Take an x out. My solutions, this could be 0. Or for this, what makes that 0? 0 or 6. Go back to your very original problem. I'm checking to see if 0 and 6 are okay for denominators. I could not have ended up with a 7 or a 2. I did not end up with a 7 or a 2, so I'm good. Those are my solutions, 0 and 6. Okay, I have one more example just because this is so complicated, so I'm going to do one more. This is on page 694 of your book. It's number 34. You don't have to really go there now if you just want to write this out. You can pause this, write it down. I'm choosing to do this one as a subtraction problem versus addition. But again, solving using least common denominator. So I need to find factors of the denominators first. So I just factored this. My separate factors in these three denominators are, I see a 3. This is the only denominator has a factor of 3. I see an x plus 3 shared by these two, so I only need to use it once. And I see a 5. So my common denominator is going to be what 3 times 5 times x plus 3 is. And that is 15 times x plus 3. So I'm going to multiply both sides by 15 times x plus 3. Used pencil. I'm going to start on the right again, because I find it's usually the easiest, makes me feel good. Okay, so if I'm cross-reducing, I get to cross off the x plus 3's. Why that gets blurry. Okay, I'm going to cross off the x plus 3's, and I'm going to cross-reduce. Remember, this is a 3 times 5. So I'm going to cross off the 3's and the x plus 3's, and I'll be left with 5 times 10x plus 1. I'm going to leave it like that. 5 times 10x plus 1. Okay, so remember the 15 was a 3 times 5. I crossed off the 3, so I was left with 5. Equal sign. That, doesn't that break that down nice? It's not much left to do there. So on this side, if I am doing the distributive property and take one piece at a time, my x minus 3's are going to cross reduce, and I'll be left with 15 times 10. 15 times 10 is 150. I'm going to line this up. Distributive property. So I'm going to write minus, and I'm going to put this in parentheses because I'm going to subtract whatever I get from this part of this problem. I'm going to write again that this is a 3 times 5 times x plus 3. I'm going to cross that off so that you can see that my 5's will cross reduce. But I then have, okay, so if my 5's cross reduce, I'm going to call this 3x plus 9, and I have to take 3x plus 9 times 3. Okay, so again, I multiplied this out so that it looked like it was one thing. I did the distributive property, 3x plus, and then 3 times 3 is 9, 3x plus 9 times this 3. That's what I have written right here. And I have to subtract all of that from my 150. So I'm going to multiply this out again, which is going to be 9x plus 27. Here's the tricky part with the subtraction sign. That's why I showed it all separate. 150 minus 9x. It's like the distributive property with the subtraction sign, minus 27 equals, and then I can do the distributive property on this side as well, 50x plus 5. Okay, so on the left, you are going to do 150 minus 27. I get 123. I cheated. Subtract your 5. You get 118. You could add the 9x. And you'll get 59x. Divide by 59. And you should get 2. X equals 2. Going back to original problem, the only thing I was not supposed to get was a negative 3. I'm okay with x equals 2. And that's my answer. Okay, give it a shot. The problems that you need to do are in Google Classroom. Thanks. Email me with questions.